Okay, so in today's video we're going to have a look at perpendicular lines. We're going to start off by having a look at some perpendicular gradients just to get some understanding, but I would encourage you to first make sure that you've had a look at the part 1 video in this series looking at equations of lines. You're going to have a very good understanding of that. Again, the link for that is in the description, so check that one out first if you haven't already, but we're going to get started. So grab a piece of paper, grab a pen, make some notes, and we're going to start by looking at this question here, just looking at perpendicular gradients. So on the screen I've got 4 separate gradients. We're going to have a look at creating the perpendicular gradient of these. So the first one that I'm going to have a look at over here is if we've got a gradient of 2. So if we have a line with a gradient of 2, which, thinking about what that would look like, it would be sloping upwards, something like this. Okay, so let's imagine this line has a gradient of 2. Now if we create a perpendicular line to this, it would be sloping obviously at a 90-degree angle in the other direction like this. Okay, now it's quite easy to find the perpendicular gradient, but if we think about what a perpendicular gradient would kind of look like, this original line here would have a rise of 2 and a run of 1, and that's what makes it have that that gradient of 2 there, a rise of 2 and a run of 1, or a change in y of 2 and a change in x of 1. Now if we were to rotate that 90 degrees to create this perpendicular line, which would look something like this, if you imagine now where those numbers would be, the 2 would be on the bottom there and the 1 would be on the side. Okay, so now our rise is 1 and our run is 2. Okay, so over here, although we had, let's have a look, a rise over run would be 2 over 1, which gives us a gradient of 2. This one now gives us a rise of 1 and a run of 2, and is sloping downwards, so it'd be negative, so it'd be negative a half. Okay, so just thinking visually about why we get the gradient that we do here, that's what it would actually look like there. So instead of having a rise of 2 and a run of 1, it would have a rise of 1 and a run of 2, and would be sloping downwards or in the opposite direction. Of course, if it was sloping downwards originally, it'd now be sloping upwards. Okay, so what actually happens here is something called the negative reciprocal, which is the name of this perpendicular gradient. So how do we get from 2 to negative a half just using the numbers? And that's what we're going to have a look at here. So I'm going to get rid of this, and you're going to see why we get the negative a half here just using the numbers. Let's get rid of that. Right, so first things first, we're going to look at the 2 and we're going to imagine that it's a fraction. So if it was a fraction, which seems a bit strange, it would be 2 over 1. Okay, so any number can be written as a fraction just by putting it over 1. Now to get the negative reciprocal, okay, negative just meaning that we swap the symbol. So currently it's positive, so it's definitely going to become negative. Again, thinking about that visual idea that I drew there, if it was sloping upwards, it will now be sloping downwards. And the reciprocal just means to flip it over essentially. So the 2 is going to go on the bottom, the 1's going to go on the top, and there's our gradient, negative a half, and it's called doing the negative reciprocal. Okay, so all we're going to do in all of these circumstances here to get the perpendicular gradient is to flip it over, which is called the reciprocal, and to swap the symbol in front of it. So if it's positive, it'll become negative, and likewise if it's negative, it'll become positive. So for this next one here, 1/4, if we flip it over, we get 4 over 1. It's currently positive, so it becomes negative, so it's negative 4 over 1, and 4 over 1 is just 4, so the answer, or the perpendicular gradient in this case, would be negative 4. And there's our perpendicular gradient if we have a gradient of 1/4. On to the next one. If we flip this over, so 2/5 becomes 5 over 2, just flipping those numbers over. It's currently negative, so now it's positive. I don't have to emphasise that it's positive there, I can just leave it as 5 over 2. I could put a plus sign in front of it, but we don't have to. We'll assume it's positive if there's no negative symbol. So that would be 5 over 2, which we could write as a decimal as well. We could write that as 2.5. Again, remember you could actually just turn it into a mixed number. 2 goes into 5 twice with a remainder of 1, so it's 2.5 or 2.5. Absolutely fine for you to leave it in either way, just whichever you prefer. We'll have a look at when we might use decimals or fractions later on. And the last one here, negative 3. Remember that currently is a fraction. I'm just going to put a 1 underneath it up here. So it's negative 3 over 1. Flip it over and it becomes 1/3. And again, it's positive, so it just stays as 1/3, and we don't have to worry about converting that or writing it as a decimal. We can just leave it as 1/3. There we go. So that is the process we're going to use throughout the topic here. And there is just one extra little thing that I do tend to do when I'm writing down the gradient. So if we refer back to this 2 over here, when I'm referring to the gradient, I label it as m equals 2. Okay, just referring back to our equation of a line that we looked at in the last video, y equals mx plus c. The m there represents the gradient. So when I'm labelling the gradient, I say m equals 2. And when I'm labelling the perpendicular gradient, which is what I've done here, -1/2, I do m again, but I put a little mini p with it just there, say mp, and that is how I label the perpendicular gradient. Okay, so I say mp equals -1/2, and it's a good little exam technique as well, just to show that you are actually aware of what you are doing here. You're finding the perpendicular gradient. So I'm going to be using that throughout the video as well. Okay, so m equals is for the gradient, and mp equals is going to give me my perpendicular gradient, my negative reciprocal there. Let's have a look at seeing how we can approach this in some questions. Okay, so it says find the equation of a line perpendicular to y equals 1/2x minus 3 that passes through the point 3, 4. Now first things first, I'm going to write down what the gradient is up here. So the gradient equals 1/2. There we go. And I need to find a perpendicular line to this that passes through a particular point. Now straight away, I can write down my y equals mx+c, but I need to work out what my gradient actually is. Now if it's a perpendicular line, I need to find the perpendicular gradient of 1/2. So first thing I'm going to do is I'm going to write that down. So mp equals, flip it over and change the sign, we get -2/1, which is -2. And again, you can write that down as -2/1 and then simplify it down to -2 if you want. But there we are, that's the gradient we're going to be using, -2. So just like before when we've done this, put your -2 into your line equation. So y equals -2x plus c. And we're going to start to figure out the equation of this line. Now we don't really need to know the fact that it has a -3 at the end. It doesn't really matter what the y-intercept of that line is. All we really need to know is what the point is that our line is going to go through, and that's 3, 4. So that -3 up there doesn't really do anything for us, okay? So we can actually just ignore the y-intercept of that line. Right, so if we stick this point in, then we've got 3, 4 to put in. So y is 4, so put 4 in place of y. And then 3 is x. So we'll sub that in, so it's -2 times 3 plus c. And then we just need to simplify this down, get rid of that bracket there, and solve this for c. So 4 equals, -2 times 3 is -6 plus c. And adding 6 to both sides there to get c on its own, to isolate c, add 6 to both sides, we get 10 equals c, or c equals 10. And now we've got c, we can write our line equation, just replacing this c with the number that we want, the number that we found there, 10. So we get y equals -2x plus 10. And obviously you could write that in a different way as well. You could write 10 minus 2x and swap them round, but that's absolutely fine just to leave your answer like that. So y equals -2x plus 10. Let's have a look at another one. Okay, so find the equation of a line perpendicular to y equals 2 minus 3x that passes through the point 6, 5. So first things first, let's get the gradient out of this. Now it's written in a slightly different way because it's got a negative gradient, but our gradient there is -3, the number in front of the x. So let's write that down, m equals -3. Straight away we're finding a perpendicular line, so let's find the perpendicular gradient. So mp, change it to positive, flip it over, it becomes 1/3. Right, so we just need to put 1/3 into our line equation, so writing down y equals mx+c. And then let's put this gradient in. So we get y equals 1/3 x plus c. Right, from there, same process again. So we're going to sub this coordinate in, 6, 5, as that coordinate is on our line. So 5 equals y, so 5 equals 1/3 times the x coordinate, which is 6, plus c. Right, let's expand that little bracket out. So we get 5 equals, now 1/3 times 6. You can treat this in two different ways. You could do a bit of working out for this if you want. If you times 1/3 by 6, remember 6 is 6 over 1, so you can just treat it like normal fractions. You get 6 over 3, and 6 over 3 equals 2. And when you times a fraction by a whole number, it just multiplies the numerator. So 6 times 1/3 is 6/3, and 6/3 is 2. Okay, but you can also just think when it's a fraction times 6, if it's a nice one, 1/3 of 6 or 1/3 times 6 is just 1/3 of 6. So 6 divided by 3 equals 2. So you can do it in two different ways there. Just depends how confident you are with your fractions here. But you can always just treat it in this sense up here. So 6 times 1/3 is 6/3, and simplify it down. And in this case, it does become a whole number. So 5 equals 2 plus c. And then again, if we solve that for c, subtract 2 from both sides, we get 3 equals c, or c equals 3 as our value of c there. There we go, so we've got our y-intercept now. We can put it back into this line equation, and we get y equals 1/3 x plus the 3 there that we've just worked out. And there's the equation of our line, 1/3 x plus 3. Okay, right, so here's some for you to have a go at. Okay, so there's two questions there. Have a go, write down the gradient of the line, write down the perpendicular gradient, stick it into y equals mx plus c, and then sub those coordinates in that are on the line there to find your line equation. So pause the video there and we'll go over the answers in a sec. Okay, so working these out. So the first one there, the gradient is currently 1/3. So our perpendicular gradient is going to be -3. Putting that into our line equation, y equals -3x plus c, and then let's sub that coordinate in 2, 5. So we get 5 equals -3 times 2 is -6 plus c. Add 6 to both sides, 11 equals c, and then sticking that into our line equation to finish it off, y equals -3x plus 11, and there's the equation of our line for the first one. On to the second one. Our gradient for this one is -4, that -4 there in front of the x, so m equals -4. So our perpendicular gradient is going to be +1/4. There we go, so +1/4 is our gradient. Sticking that into our line equation, y equals 1/4 x plus c, and then subbing in our coordinate there, which is 8, 3 this time. So 3 equals, and I'm going to write the working out for this one, 1/4 times 8 plus c. And we can do 1/4 of 8 there, or 8 quarters, we get 2. 1/4 of 8 equals 2. So 3 equals 2 plus c. Take away 2 from both sides, we get 1 equals c. And we can plug that in place of c there for our equation to finish it off. So y equals 1/4 x plus 1. There we go, and there's the equation of our line for that one. Right, let's have a look at something else. Okay, so what we're going to have a look at is some equations of lines where it isn't in the form y equals mx plus c. So whenever we're looking at lines, we need it to be in this form here. Now it can be written in other forms, we can use them perfectly fine, but in order to compare them and in order to find out the gradient, it needs to be in this form here. So looking at this question, it says, here are the equations of 4 straight lines. 2 of the lines are perpendicular, which 2? Now if we look at this first one, it's not in the form y equals mx plus c. Okay, it has a 2 in front of the y, so in order to get it into the form y equals mx plus c, we're going to have to divide everything by 2. Okay, so I'm just going to write divide by 2. I'm going to divide both sides by 2, so 2y divided by 2 gives us 1y. We've got 1x there. 1 divided by 2 is a half, so that 1x would become a half x. And the 1 divided by 2 at the end would become a half, so that's plus a half. There you go, half x plus a half. So there's my first one. Let's have a look at the next one. Now this doesn't have anything in front of the y, but it does need rearranging. Look, the x there is on the left hand side of the equal sign. So if we add or plus 2x to both sides, we would get y equals, and just to keep it so that the x part's here, although I don't have to, I'm going to stick it in front of the 4. So y equals positive 2x, so as it's in front of the 4, I don't have to put the plus sign. But there we go, we get 2x. And then we do have to introduce the plus sign for the 4 there, so plus 4 as it is positive 4. There we go, 2x plus 4, and that's my second one. So look at the third one, what we're going to do for this one. Okay, so we've got a 3 in front of the y, so we need to divide everything by 3 so that it says y equals. Don't have to rearrange it at all, but dividing everything by 3. So dividing that by 3, we get y equals, 6 divided by 3 is 2. So 2x, so 6x divided by 3 is 2x, and then add 5, and 5 divided by 3, let's leave that as a fraction, 5 over 3. That just means 5 divided by 3 there, rather than trying to actually work that out. So 5 over 3 is fine, as we are also looking at the gradients here to decide which two are perpendicular, because that's what we're trying to have a look at, which ones are perpendicular. We don't really need to worry about the y-intercept there, okay? But there we go, let's have a look at this last one. Okay, so nothing in front of the y, but the 2x is in the way here, so we need to minus 2x from both sides to get that out of the way. And again, just like before, I'm going to put it in front of the 3. So y equals, we're subtracting 2x, so minus 2x. There we go, and then that is positive 3 again, so plus 3. Right, so we need to have a look at which ones of these are perpendicular. Now, as we've got, and let's see if we can highlight this, we've got a 2x and a 2x here. So those two lines there are parallel. Not asking for which ones are parallel, but they have the same gradient, so we could say that those two are parallel. So let's have a look at the other two. So we've got these two here. So the gradient of the one at the top, so the gradient of A is a half, and the gradient of D down the bottom there is -2. And if we think about this, if half is my gradient, my negative reciprocal would be -2, wouldn't it? You'd flip it over, it'd be -2/1, which is -2. So therefore those two lines must be perpendicular, okay? So it's just something to be thinking about in terms of different line equations, what they can look like and the way we want to have them. We want to have them as y equals, we don't want any numbers in front of the y. If we do, we're going to divide it. And if there's anything next to the y, we just want to move it over to the other side, okay? But they're A and D there are my two lines that are perpendicular. But we're going to be having a look at some line equations next, where they might not necessarily already be in the form y equals mx+c, and that just hints to you that you do have to change them first. Let's have a look at one though, so you can have a go. Okay, so this question says find the equation of a line perpendicular to 5y equals 2x minus 4, and that passes through the point 3, 4. Okay, so here's our line equation, 5y equals 2x minus 4. So to eliminate that 5y there, just to make sure we've got a 1y, we're going to divide everything by 5. And let's see what we get when we do that. And we definitely get our y equals 2 divided by 5 isn't very nice. We could write that as a decimal if you want, but I'm just going to leave it as a fraction. And the reason I tend to leave it as a fraction, particularly to start with, is it's a lot easier to do negative reciprocal of a fraction than it is as a decimal. In fact, if I did have it as a decimal, I'd actually convert it back to a fraction so that I could do my negative reciprocal there. But we get 2/5 x minus, and not that we're going to need the y-intercept, but let's get it right, 4/5 as well, just dividing it by 5. So that is the equation of the line that we want, because we can now do our gradient and negative reciprocal here. So our gradient at the moment is 2/5, our number in front of x there, and our negative reciprocal of that, if we flip it over and change the symbol, we get minus 5/2. There we go, which we could also write as minus 2.5 or 2.5 and convert it if you want, but I'm just going to leave it as 5/2 for the moment. Alright, let's put that into our line equation then. So y equals minus 5/2 x plus c. So same as before, we're going to sub this point in, use that to help us find c, but we've not got a nice gradient for this one. We've got minus 5/2 or 5/2, or 2.5 if you want to convert it. I'm just going to leave it as it is. So sticking our coordinates in, y is 4, so 4 equals negative 5/2 times 3, so subbing in 3, plus c. Now you might make the case here that it might be easier as a decimal, but if it's not this kind of fraction here where it is 2.5 or it's something else, you're going to want to leave it as a fraction. So you might think at this point, okay, well I'd probably just do 2.5 times 3, which is quite nice and easy to do. I'm actually going to avoid doing that for the moment. I'm just going to leave it in fractional form. Just makes it a bit easier with some of the harder questions where maybe the decimals aren't as nice, if it's thirds or if it's sevenths or something like that. Right, so let's work it out. So 4 equals negative 5/2 times 3. Well, always just imagine this as a fraction, times the top times the bottom. So we've got negative 15/2 plus c. There we go. Minus 15/2. Obviously, if it's not a nice decimal here, you can actually just convert that into a mixed number. Okay, so minus 15/2 is the same as minus 7 1/2. 2 goes into 15. 2 goes into 15 7 times with a remainder of 1. So let's just rewrite that. So 4 equals minus 7.5 plus c, and that's just quite nice and easy now to add to 4, isn't it? So we can add 7 to 4, which is 11, add the extra half, which is 11.5. So if we add 7.5 to both sides, we get c equals 11.5, which again you could write as 11.5, but just for the case of some of the harder questions, I'm going to leave it as a fraction. Right, so plugging that in place of c, we get y equals minus 5/2x plus 11.5. There we go, and there's our final answer. A little bit weird there actually to have it as mixed numbers and improper fractions there, so I probably would change that. I'd probably put y equals negative 2.5x plus 11.5. There we go. It wouldn't actually be wrong to leave it how I already had, but I just don't really like to have improper fractions and mixed numbers in the same question. There we go. So y equals negative 2.5x plus 11.5. Of course, again, you could write it as minus 2.5x plus 11.5. Absolutely fine to write your final answer as a decimal. Right, so just little bits to be thinking about there. Obviously, when you do get, and I'm just going to highlight it down here, when you do get this scenario going on, do just leave it as a fraction, okay, and then convert it back to a mixed number so that you can add it and find your c if that scenario does arise. I've got one here where it does arrive, so you're going to have a go at it now. So I'll flick to that. Okay, so there's two questions here. Have a go, pause the video there, and we'll go over the answers in a sec. Right, okay, so let's have a look at these. So the first one, find the equation of this perpendicular line to this one, and it goes through this point here. So first of all, we need to divide it by 3. So y equals 2 divided by 3 is 2/3, and 5 divided by 3 is 5/3. There we go. So our gradient there at the moment is 2/3, and our perpendicular gradient will be negative 3/2, flipping it over. Putting that into our line equation, let's have a look and see what we get here. So y equals negative 3/2x plus c, and now we can substitute that point in 3 and 7. So 7 equals negative 3/2 times 3 plus c. Times that out, we get 7 equals minus 3 times 3/2 is minus 9/2 plus c. And that's 4.5 or 4.5. So if we add 4.5 or 4.5 over to 7, 7 plus 4 is 11, plus the extra half is 11.5. So 11.5 or 11.5 equals c. And now we can plug that in place of the c up here. Again, you can write it as your mixed number, your decimals, or you could have kept it top heavy if you'd have wanted. But let's write it all in. So y equals minus 1.5 or 3/2, doesn't actually matter, just personal preference here, and then plus the 11.5. There you go. So you could have written minus 3/2x, okay, or you could have written minus 1.5 and 11.5 there. As long as it's the same numbers, doesn't really matter how you write them. There we go, and there's the equation of that line. On to the next one. So at the moment it's not in the format we want. We need to add the 3x over as well. So if we add that over, we get 5y equals 3x plus 2. Divide everything by 5. We get y equals 3/5 x, 3 divided by 5, plus 2/5. Not that we need that one at the end, but there we go. And then we can write our gradient. So at the moment, the gradient is 3/5. And our perpendicular gradient, if we flip that over, we get minus 5/3. So minus 5/3. Right, let's put it in place, see what we get. So y equals minus 5/3 x plus c. And now let's sub in that coordinate there, 3, 4. So 4 equals minus 5/3 times the x coordinate there, which is 3, plus c. Let's times that out. So 4 equals 3 times 5 on the top there, remembering it's 3/1, so minus 15/3 plus c. 15 does actually divide by 3, so 15/3 becomes 5. So we have 4 equals negative 5 plus c. And adding 5 to both sides there, we get 9 equals c, or c equals 9. And then again, we can put that in place of c in our line equation. So what do we get? We get, let's write this up here, we get y equals minus 5/3 x plus 9. There we go, and that is our line equation. And again, you could write negative 5/3 as negative 1 2/3. You could write that in another format if you wanted to there, but absolutely fine just to leave that as a fraction. Right, so there's those two. Let's have a look at something slightly different. Okay, so a line passes through the points 1, 5 and 5, 7. Find the equation of a perpendicular line that passes through the point negative 1, 7. Now this doesn't give us a line equation, which means we don't have a gradient, which means we're going to have to work one out. So we have been given this information that a line passes through these 2 points. Obviously, if you remember from the last video, we can have a look at the change in y over the change in x to get the gradient, so we don't even need the line equation. Because we've got these 2 points, we can find it ourselves. So going from one point to the other, the change in y, which we're going to do over the change in x, but the change in y goes from 5 to 7, which is a change of positive 2, and the change in x goes from 1 to 5, which is positive 4 or 2/4. So if we simplify that down, we get a half. So our gradient at the moment is 1/2. So if I want the perpendicular gradient, which we do for this because we're looking for a perpendicular line, we'll do the negative reciprocal. So negative 2 over 1, which is negative 2. Right, there we go. And now we can put that into our line equation. So y equals negative 2x plus c. And then again, just like before, we can sub in our coordinate. So 7 is the y coordinate, which equals negative 2 times x, which is negative 1, plus c. Negative 2 times negative 1 is positive 2. Those negatives cancel each other out, so 7 equals 2 plus c. Solving that, take away 2 from both sides to get c on its own. We get 5 equals c, or c equals 5, and we can put that back in place of c up here. So y equals negative 2x plus the 5 there. There we go, plus 5. And there's the equation of our line. Okay, so for this question, it's all the same process, but you're just going to have to find the gradient first. So I've got one for you to have a go at. Don't forget your change in y over change in x. Don't forget if you're going from one coordinate to the other to keep that consistent with the x and the y. But here we go, here's one for you to have a go at. Okay, so here's a question for you to have a go at. So pause the video there, have a go, and we'll go over the answers in a sec. Okay, so a line passes through these 2 points. So let's start off by finding the gradient. So change in y over the change in x. So the change in y goes from negative 5 to negative 1, and that is a positive 4. It's going up 4 from negative 5 to negative 1. Then from 2 to 10 for the x coordinate, that is 8. There we go, 4 over 8. And if you simplify that down, you get 1 over 2. So you get a half again for this one. So our perpendicular gradient, flip it over, put it with a negative, negative 2. And we can actually put this now into our line equation. So y equals negative 2x plus c. Now we can put in our coordinates there. So we've got 4, 3 to stick in. So 3 in place of y. So 3 equals negative 2 times 4 plus c. Expand that out. So 3 equals negative 8 plus c. And then solving that for c, add 8 to both sides, we'll get 11 equals c, or c equals 11. And then finishing it off just like before, putting it in place of c there, we'll get y equals negative 2x plus this 11 here. Right, there we go. And there's the equation of the line. Right, I've got one more question for you to have a go at before we finish, just sort of putting all this together and seeing what you can do. Let's have a look at it. Okay, so this is the last question here. There's nothing that we've not done throughout the video to actually be able to answer this, but it might be a good idea for you to just pause the video there, have a go, see what you get, and we'll go over the answers in a sec. Okay, so hopefully you've had a go at that question there. Let's have a look. It says, here's the line equation. Find the equation of a perpendicular line that passes through the point 3, negative 5. So we've got the line up here, 3y equals 4x plus 7. So we're going to have to get that in the form y equals. So let's divide everything by 3. Okay, so that's the first step. Divide by 3. So if we do that, we get y equals 4/3 when we divide that by 3. X plus 7/3, dividing everything by 3 there. And then we've got our gradient. So our gradient of that line is 4/3. Now we can find the perpendicular gradient. So flip it over with a negative, negative 3/4. And now we can just take that same approach that we have on all the previous questions. So sticking our gradient into our line equation, we get y equals negative 3/4 x plus c. And then we can put our coordinate in, and our coordinate there is 3, negative 5. So minus 5 in place of y. So minus 5 equals negative 3/4 times 3 plus c. Expand that out. So minus 5 equals 3 over 1 times 3/4 is negative 9/4 plus c. And then we need to add 9/4 to the other side. Again, this is one of those scenarios where I would look at this as a mixed number. So if we convert that into a mixed number, let's do that to the side. Minus 9/4 is the same as minus 2 1/4. 4 goes into 9 twice, so minus 2 1/4. So if we add 2 1/4 over to negative 5, we need to just be able to work that out there. So if we add 2 to negative 5, that gets us to negative 3. Add the extra quarter, gets us to negative, I'll go back to my normal colour there, negative 2 3/4. Okay, add 2 to negative 5 gets you to negative 3. Add the extra quarter gets you to negative 2 3/4. It's obviously nice and easy if you have a calculator here, but you just got to be careful with your negatives, particularly when it's fractions. So negative 2 3/4 equals C. And now we can plug that into our line equation. So piecing this all together, let's have a look. We've got our value of C there, we've got our equation here, and we just need to piece that all together. So y equals negative 3/4 x minus this 2 3/4. There we go. And there's the equation of the line. Sorted. Right, okay, so that's the end of the video. That's perpendicular lines. We're going to have a look at some equations of circles and build this up to tangents to circles on the next videos. But that's the end of that one. So if you found that useful, if it was helpful, please like, please comment, please subscribe, and I'll see you for the next one.